Question for you. When you're building a wall or you're building a deck as you see in these two pictures, how can we ensure that the wood is meeting at a 90-degree angle? So I want my studs here to meet my base plate or meet the top plate at 90 degrees. Likewise on a deck, I want my joists to meet the end plates at 90 degrees. How can we make sure that that is a 90-degree angle? All right, protractors. Protractors, the ones that come in your math set, they're great for figuring out angles on a piece of paper, but they're not very applicable to a big work site. It's an extra tool that can get lost, and quite often they're not accurate enough when you're dealing with larger scale things like a wall or a deck. If you were to go to a construction site and ask one of the carpenters, what's Pythagorean theorem? They might look at you and say, I have no clue what you're talking about, or they might say, that's that thing that I learned back in grade 9 math, but I don't really remember what it is or how it works. If you were to ask the same construction worker, what's the 3-4-5 rule? They'd have no problems telling you what that is. I want to discuss with you the 3-4-5 rule. If myself or a construction worker were carpenter, we're building a deck or a wall, as I mentioned already, we want to make sure that the corners are square. Now, square is not a shape when it comes to carpentry. Square means 90-degree corners. So as a carpenter, I want to make sure my walls are square. Why is that? If I was to put a piece of drywall or a piece of plywood on that wall, we know that drywall and plywood come with 90-degree corners. We want to make sure that it's going to line up with the wall. A little bit of an exaggeration here, but if my wall was not square and I tried to put a piece of square drywall on it, we can see that the edges of the drywall are not matching up with the edges of the wall, like in my first square diagram. So that's the reason why. Here's what I would do. So just backing up here. So I lay out my wall and I want to see, is it square? As a carpenter myself, I would pick one corner and I would measure 3 feet. Now, in Canada, I know we use the metric system, but when we're dealing with carpentry, we still use the imperial system because that's what the United States south of us uses, and we get a lot of our construction materials from them. So in carpentry, we still use imperial. So instead of meters and centimeters, we use feet and inches. So I would measure 3 feet with my tape measure. It's a tool I already have in my tool belt. From the same corner, I would measure out 4 feet. And at the end of these measurements, I would put a little pencil line. And then from the pencil line to pencil line, I would measure. If I get 5 feet, that tells me that I have a 90-degree angle, that this wall is square. That rarely happens on the first time. Usually when I measure, I'll get something like 4 feet, 11 inches. There's 12 inches to a foot, so I'm an inch short here of 5 feet. That tells me that my wall is not square. So I would come over to one of the other corners and I would kick it and push it and adjust it a little bit. And I'd come back and measure this red line from pencil line to pencil line. And the second time around, I may get 5 foot 1 inch. Still not square. So I'd maybe go to a different corner and give it a kick again and adjust it, and I come back and measure. The third time I measure it, boom, right on. 5 feet, 0 inches. 5 feet exactly. That tells me that I have a right angle triangle, or a square framing, square wall or deck. And then I could proceed and start putting top boards on or drywall, that sort of thing, or any extra screws or nails that I need to put in the wall. So that's the 3-4-5 rule. The 3-4-5 rule works like this. If I can replicate it out here, So if one side is 3 and the second side is 4, we know that in order for this to be square, the third side has to be 5. And this also works for 3 centimeters, 4 centimeters, 5 centimeters, 3 meters, 4 meters, 5 meters. It works for whichever unit you want to measure in. The 3, 4, 5 rule is also known as the Pythagorean Theorem. And just to decode that for you, theorem is sort of a fancy word for a math idea. And Pythagorean, this is named after this Greek dude that lived a while back called Pythagoras, or named Pythagoras. And Pythagoras came up with this neat math idea, and it's been named after him, the Pythagorean Theorem. So it's Pythagoras' great math idea. What he noticed was this. If we take this first side of a right angle triangle, the 3, and we square it, we know that 3 squared is 9. But I'm actually going to draw it out for you. So here is a square that is 3 long and 3 wide, and we can see that it has an area of 9. If we do the side for 4, the same for the side with 4, so this is 4 long and 4 wide, so it's a 4 by 4 square. We know that it has 16 squares in it. What Pythagoras noticed was this. In any right angle triangle, if you add the square of this side together, so 9, and the square of the second side together, so 16, it should equal the square of the third side. So let's find out what the square of the third side is. Let's square 5. So we know 5 times 5, or 5 squared is 25, but I'll actually visually show it for you as well. So here's a 5 by 5 square, and we can see that it has 25 squares, or an area of 25. So Pythagoras said that if we add the squares of the first 2 sides together, they should equal the square of the second side. And sure enough, we can see that is true. This only works for right angle triangles. So it doesn't work for triangles that, like acute triangles or obtuse triangles. It only works for right angle triangles. And that's why carpenters are able to apply it to the 3, 4, 5 rule, or they renamed it the 3, 4, 5 rule. They want to take that triangle and make sure it's a right triangle. So they apply Pythagorean theorem to that. This works for other numbers as well. 3, 4, 5 is just a convenient set of numbers that carpenters know that works for sure. So hence the 3, 4, 5 rule. So tomorrow in class we will be looking at this in a little bit greater detail, and we'll be practicing some different questions. Before we do that, nice picture of a finished deck. Nice right corners I see there. Obviously that carpenter has applied the 3, 4, 5 rule. And a house that is beyond just a wall, but it's not quite finished. Still needs the drywall and the plywood put up. Looks like we have a lot of nice right angle or square walls. All these studs look like they are at a right angle, which is fantastic. Looking at this though, can you think of any other concepts that we've learned this year that are applicable to building a house? And do you see any other applications of Pythagorean theorem that we could use in this picture other than just making sure that studs are at a right angle or walls are square?